In this lesson, we're going to learn about the imaginary number called I. Before we do so, we need to look and review a little bit about real numbers. And recall that real numbers are numbers that can be placed on a number line. So here we have a number line, and already on the number line we have several different types of numbers. We see that we have the natural numbers, numbers 1, 2, and 3, and if you kept counting upwards, those are all the natural numbers. The whole numbers would be including 0, so 0, 1, 2, 3, 4, 5, etc. Those would be the whole numbers. The integers, when we say integers, that now adds into it the negative numbers, so on this number line we see -1 and -2. So those are integers, but real numbers also include rational numbers being numbers that can be written as fractions. So it has numbers like 1/2 or 1.75 is also a rational number. We've got negative rational numbers, -1 and 1/2, -2/3. And remember that -2/3 can be written as a decimal, -0.66666 forever. Okay. But real numbers also include irrational numbers, things like pi. We can evaluate where pi is on the number line, or the square root of 5, or any of our square roots of non-perfect squares, square root of 2, square root of 7. We can find those on the number line by narrowing down what they are between. So these are real numbers, any number that can be placed on a number line. So where on this number line could I place the number I? Well, we haven't had the definition yet of I, so let's define that. I, the definition of it, is that when you square this number, you're going to get -1. Which, when you think about that, also means, therefore, that I is equal to the square root of -1. This isn't technically the definition, but it is part of the definition. The real definition is that a number squared equals -1. That is called the number I. And we know that no real number squared can be negative, because a negative times a negative is a positive, and a positive times a positive is a positive. So there's no real number that we can square to get this. So we call this, it's part of an imaginary number, and there are infinitely many imaginary numbers. The I is just part of it. It's called the imaginary unit, and imaginary numbers are actually written in the form of BI, where B is a real number. So think about all those numbers that are on that number line up there. We can have any one of those numbers be the letter B, be represented by the letter B, and then I, which has the property of I squared, is -1. So we could say 2I or 3I. We could say -2I or -1I. We could say -1.5I, -2/3 I. Similarly, we could also do irrational numbers. We could say the square root of 5I, or we could say pi I. All of those would be considered imaginary numbers. So there's infinitely many imaginary numbers, just like there are infinitely many real numbers. Let's learn a little bit about one aspect about this number I. We'll talk about the powers of I. We're going to use the same rules that we use for exponents in the real number system, and that is that anything to the 0 power is equal to 1, so I to the 0 is equal to 1. And I to the first, well, in our knowledge of exponents, we know anything to the first power is just itself, so I to the first is just I. I squared, well, we know that because that's the definition. I squared is equal to -1. And then we get up to the power of the third power, I cubed. Well, now this one's a little bit more interesting, so we have to think about it based on what we know right above it. How can we break up I cubed? Well, we could write I to the first times I to the second, because whenever you multiply like bases, you add the exponents, the 1 and plus the 2. But in our list right up above, we can see that I to the first is just I. And we also can see in our list up above that I squared is -1. So I cubed becomes I times -1. And when we multiply those together, we just get -I. So here's the first 4 powers of I. I to the 0 is 1, I to the first is I squared is -1, and I cubed is -I. But let's go on, let's look at several more powers of I. Let's try I to the fourth, and we're going to use that same process that we did with I cubed by breaking it up, and we notice that I to the fourth can be broken up into I squared times I squared. And by definition, we know that I squared is -1, so that's just going to be -1 times -1, which is positive 1. But if we look at that list right up above, we already have something that equals 1. I to the 0 equals 1. So we could just say that I to the 0 equals 1 and I to the 4th equals 1 and write them on the same line there. And I to the 5th, if we break that up, I could break that up into I squared times I cubed. Well, we know that I squared is negative 1, and then from the list, I cubed is negative I. A negative times a negative is a positive, so we get positive I. And once again, I see that I's already on that list, so I'm going to write my I to the 5th there on that list. You might start noticing that there's a color coding going on here. I to the 6th, well, I could break that up, all of these, I could break them up in more than one way. I'm going to break that up as I to the 5th times I to the 1st. You could break that up as I squared times I squared times I squared, or I cubed times I cubed. But regardless of how you break it up, you're going to end up with the final result being the same. With I to the 5th times I to the 1st, I get I times I, which is I squared. And we know I squared is negative 1, which is on that list up above. So I'm going to say that I to the 6th goes on that same line with I squared, since they both equal negative 1. I to the 7th, well, I guess you're going to assume right now it's going to be negative I. Let's find out. It breaks up to I cubed times I to the 4th, which is negative I times 1, which is, you did guess it right, negative I. And so I'm going to put that in the list. Well, you might say, well, there seems to be a pattern here. Some of you might be looking at this and noticing you see a pattern. And based on that, let's do some guesses here. I to the 8th. What do you suppose I to the 8th would be? Well, it follows after I to the 7th. So you might guess, you guessed correctly, that it equals 1. And what about I to the 9th? I to the 9th, well, that follows after I to the 8th, so it does, in fact, equal I. And what about I to the 10th? I to the 10th follows after I to the 9th, so, yeah, it's negative 1. But let's skip a few right now and go all the way to I to the 18th. What do you suppose I to the 18th might be? Well, you could start counting it out and counting down until you finally get there, and the answer is it's negative 1. But what about I to the 43? Now that's going to be a lot harder to count out. So I'm going to tell you right now that that's negative I. And if we look at our list, negative I is the same as I to the 3rd. So you might be looking at I to the 3rd and I to the 43rd and try to figure out, well, they both end in 3. I don't know if that's it. I'm not sure that that has anything to do with it, but how about I to the 1,624? Way too many to count out, but I will tell you right now that I equals 1. Well, I to the 0 and I to the 1,624, but they don't end in the same digit. So that's not it. But this number, 1,624. And how many numbers do I have in the list over here? Well, the pattern is that it's I to the remainder of that exponent when you divide it by 4. These kind of numbers, when I want to know what the remainder is divided by something, are called modulo. So something like 15 mod 4 is 3, because when 15 is divided by 4, you're going to get 3 with a remainder of 3. 21 mod 4 is 1, because 21 divided by 4 is 5 with a remainder of 1. 324 mod 4 is 0, because 324, when divided by 4, it goes in evenly and there's no remainder. So it ends up that all we need to know are these 4 powers of I and the ability to divide any other power by 4 to figure out what its remainder is. And the pattern is always going to be, when I'm thinking of the remainder of 0, 1, 2, and 3, I get either 1, I, negative 1, negative I. So you're going to want to memorize this list. And once again, that's 1, I, negative 1, negative I. 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 If you memorize that list, you'll be able to find any power of I. So this is the first little lesson, an introduction into the imaginary number system, where we know we have the imaginary unit I, and all imaginary numbers are in the form of bi, a real number times the imaginary unit.